All right, we are starting off a new unit, Unit 7, and we are headed into studying a new type of function. So, to recap, we have talked about linear functions like y equals mx plus b, the graph makes a line. We've talked about quadratic functions, anything that has x squared and it makes a parabola. And we've talked about other polynomial functions, whether it's a cubic function or a quartic function or really any other degree. And in Unit 7, we're going to explore a different type of function called an exponential function. So an exponential function looks like this. So we have f of x equals a times b to the x. So a couple things to note is that our x is the exponent. The x is the exponent, and that's why it's called an exponential function. And that's different than when we have like x squared. Even though there's an exponent there, the exponent is a 2, not the x itself. Okay, so a is our initial value. And this will also tell us the y-intercept. B is our base. B is our base. And the value of B tells us whether we have growth or decay. So if B is greater than 1, it's called exponential growth. And if B is between 0 and 1, we have exponential decay. So if it's between 0 and 1, we have exponential decay. So what do these functions look like? So let's say, for example, I have this function right here. So for example, let's say I have f of x equals 3 times 2 to the x. 3 times 2 to the x. And we're going to sketch a graph of this. So I want to make an XY table. I'll go -2, -1, 0, 1, 2, 3. All right, let's actually start with 0. We'll deal with the negative numbers in a second. But what do I get for f of 0? F of 0 means I'm going to plug in 0 for x. 3 times 2 to the 0. Now, you have to remember to follow PEMDAS, which means we have to do exponents before multiplication. So, 2 to the power of 0. Anything to the power of 0 is 1. So, if I plug in 0, I'm just going to get 3 because I'm doing 3 times 1. Let's try f of 1. 3 times 2 to the first. That's 3 times 2 because 2 to the first is just 2. So I get 6. F of 2, 3 times 2 squared. 2 squared is 4. So I'm doing 3 times 4 or 12. F of 3, 3 times 2 cubed. 2 cubed means I do 2 times 2 times 2, which is 8. And 3 times 8 is 24. Now, before we fill in these negative ones, I want you to look at these numbers and see if you notice any pattern. I'm not adding a constant amount because I go plus 3, plus 6, plus 12. But what the pattern is we double every time. Times 2, times 2, times 2. And that is because our base is 2. Our base is 2. We're going to double every time. So if I did 4, I would know that my output would be 48, even without plugging it in, because it's going to follow that pattern. Okay, now let's deal with those negative numbers. What happens when I do f of negative 2? So I'm going to have 3 times 2 to the negative 2. Okay, so I know it's been a while since we've talked about this. This was like way back at the beginning of the year. But when you have a negative exponent, you have to flip it. So anything that has a negative exponent gets flipped to the denominator. So I would have 3 over 2 squared. So that gets flipped, which gives me 3/4. Okay, 3/4. F of negative 2. All right, f of negative 1. 3 times negative 1. Whoopsie. My bad. 3 times 2 to the negative 1. X is our exponent. All right, so again, I need to flip this. So this becomes 3 over 2 to the first, which is just 3 over 2. And again, this does follow the pattern. 3/2 is 1.5. And if I double 1.5, I get 3. 3/4 is 0.75. 0.75 doubled is 1.5. So if you want to write this out, you can. 0.75, 1.5. And every single time, we are doubling. We are doubling. Okay, so what does this graph look like? Well, first of all, can you figure out if this is going to be exponential growth or decay? Yeah, because our base, the b value, tells us whether we have exponential growth or decay. So in this case, our a value is 3, and our b value is 2, which means we have exponential growth. We have exponential growth. So when you make your graph, I want you to make it like this, actually. 1, 2, 3, 4. 1, 2, 3, 4. And let's see here. We'll have each of these go by 3. 3, 6, 9, 12, 15, 18, 21, 24. All right, so I'm going to plot these points here. Negative 2, just above the x-axis. Negative 1, 0, 3. And remember, there's our a value. And the initial value is always going to be the y-intercept. 1, 6, 2, 12, 3, 24. All the way up there. All right, so when you graph this, be very careful. This function does not touch the x-axis. It gets really, really close to it, but it does not actually touch it. And that's because, if I continued the pattern into the negatives, the only thing that's going to happen is we're going to cut this in half every time. So if I cut it in half, it's 0.375. If I cut it in half again, it's a smaller decimal and a smaller decimal, a smaller and smaller and smaller decimal, but we never actually get to 0. We never actually get to 0. So in this case, we would say that the x-axis is an asymptote. The x-axis is an asymptote. An asymptote is a line that the function gets really, really, really close to, but doesn't touch. So it's kind of a weird word, so I want you to try to say it. Asymptote. Asymptote. You almost don't say the P. Asymptote. All right, so this is exponential growth. This is an exponential function. Basically what happens is it starts off really, really, really slow, and then it takes off. So it's growing really fast. And what we'll find is that if we have exponential decay, the graph will decrease. The graph will decrease. All right, let's try some more examples here. Example 2. Identify A and B. Determine if f of x is growth or decay, and sketch a graph. Now, for these graphs, we aren't going to get super in detail. We're just going to do kind of a rough basic sketch. We're not going to make like an XY table and plug in a bunch of points and everything. Just kind of a overview. Okay, so A, f of x equals 30 times 0.8 to the x. All right, so in this case, our A value is 30 and our B value is 0.8. So based on that, we should be able to determine if f of x is exponential growth or exponential decay. And it's right here. If our base is greater than 1, it's exponential growth. And if it's between 0 and 1, it's exponential decay. Since B is 0.8, this is going to be decay. So here's how we graph this. What I would be looking for you to sketch a graph is that it's going to hit the y-axis at the A value. Our A value is always going to be our y-intercept. And in this case, it's decaying, so we're going to be decreasing. And it's going to be getting closer and closer to the x-axis, but it's not actually going to go through it. So that's not really all we need. And let me just punch this into the calculator too, so you guys can see a different picture of it. 30.8 to the x. Make sure I have a good window here. So like I'm going to need my y max to be like 50 because I know I'm going to hit 30. All right, so you can see the graph on the calculator looks pretty similar to the one that we just sketched. And if I were to continue this out, like if I made my x max to be 20, let's say, you would see that the function is going to get closer and closer and closer to the x-axis, and it's going to look like it's touching it, but it's actually not touching it. So if I hit this trace button and I'm going, you can see the y value is getting smaller and smaller and smaller. And it's just going to keep getting smaller and closer to 0, but it's never actually going to be 0. Kind of crazy. All right, let's try another one. B, f of x equals 1.5 to the x. All right, in this case, A is actually 1 because we have 1 in front of this because B is the 1.5. So when there's not a number there, that actually means that A is 1. Now, since B is 1.5, we know that this is going to be exponential growth. And for me to sketch this, I'm going to hit my y-axis at 1, and it's growing, so it's going to look like this. So let's take a peek at this one too. 1.5 to the x. Don't need my window to be all crazy for this one. Wow, so you can see really clearly here that our graph is really just like sitting right just barely above the x-axis. So it starts off really slow, barely growing, and then it just takes off. And that's what an exponential function looks like. All right, before we move forward, I want you to get your textbook out. Okay, so if you need to pause the video and get your textbook, I need you to get your textbook out, and I want you to find page 492, and we're going to be looking at example 2. So pause the video if you need to, go grab your textbook and open it up to page 492 so you can follow along. Ready, go. Okay, so let's read what example 2 says. It says, Tony purchased a rare 1959 Gibson guitar in the year 2000. That's like ancient for you guys. For $12,000. Experts estimate that its value will increase by 14% per year. Okay, so it's a really rare, expensive guitar, and then every year it's increasing in value. Use a graph to find when the value of the guitar will be $60,000. All right, so the first thing that we need to do, so step 1, we need to write an exponential function. We need to write an exponential function. So f of x equals a times b to the x. Now, a is always our initial amount. So in this case, the initial value of the guitar. Okay? The initial value of the guitar. B tells us how that value is changing. Okay? So in this case, the value is growing. It's exponential growth. So here's what we do. To find B, you're going to do 100, either plus or minus whatever the percent is. So when it's growth, we do plus. And when it's decay, we do minus. And then we have to turn it into a decimal. Write as decimal. All right, so I know that's a lot. Make sure you have it written down. And once we do an example or two, you will kind of get the hang of it. All right, so let's read the question again. We have the guitar which value is initially $12,000. So A is 12,000. Now, our percent is 14 because the value is increasing by 14%. So what are we going to do? We're going to do 100 plus 14. So I'm going to do 100 plus 14, which is 114%. But I need to write that as a decimal, which means we move it 2 spots over, making it 1.14, and that's our B value. So my function is going to be f of x equals 12,000 times 1.14 to the power of x. Okay, so now I want to find out when the guitar is going to hit a value of $60,000. And we are going to use our calculator to help us with this. So I'm going to go to my y equals, and I'm going to type this function in. 12,000 times 1.14 to the x. All right, now our window is going to be crazy here because I know I'm going to hit 12,000 and I want to know when we hit 60,000. So I'm actually going to make my y max 70,000. Let's see what we get here. All right, now here's the deal. If I hit the trace button, it allows this little cursor to show up, and then I can hit the right arrow and see when do we get to 60,000. All right, I'm not there yet, so I'm going to have to change my window. Let's go to 20. All right, hit trace again. All right, I want to know when I get to 60,000. Ooh, that's pretty close. Huh? 59,918. There's 61,000. So it happens somewhere between those two. That's pretty darn close, though. So x is 12.27. And remember, we're measuring time in years. So the guitar will be worth $60,000 in 2012 because we started measuring time in 2000. So 12 years after that, 2012. All right. Now take a look at example 3 on page 492. The value of a truck bought new, here, I'll put it here. The value of a truck bought new for $28,000 decreases 9.5% each year. Write an exponential function and graph the function. Use the graph to predict when the value will fall to $5,000. So I know some of you buy vehicles, but I know a lot of you are not quite driving yet. But when you buy a vehicle, the value of it always decreases, pretty much most of the time. Okay, the value decreases. So in this case, we are starting with a car or a truck that's worth $28,000. So I know that's my A value. Now to find the B value, we look at the percent. The percent is 9.5. And since we're decreasing, this is going to be exponential decay. So in this case, I'm going to do 100 minus 9.5, which is 90.5, which I then have to turn into a decimal, which is 0.905. So this is B. Okay, so my function is 28,000 times 0.905 to the x. And then the question asks, use the graph to predict when the value will fall below 5,000. Okay, so 28,000 times 0.905 to the x. I'm going to change this to like 30,000 because I know I'm starting at 28,000 and I'm only going to go down from there. So I want to know when we get to 5,000. So again, I'm going to hit this trace button. And I'm going to keep going. All right. 4,992.99. So $7 off. So when x is 17.27, so it will take 17 years for the truck to be at a value of $5,000. All right, that is it for the 7.1 notes. Thanks for sticking through it, and we'll see you soon.